I often start to describe chemistry as if it were some sort of a gladiator contest or, some sort of a mugging or something like that. And in all these cases, it turns out there's also some that are just sitting around like spectators. They just sit there and they watch. They don't participate in the chemistry, but they do keep the charges neutral. So let's take a look at an example of this, and we'll see one of the ways that we can trim that out and make the change really obvious. So what you see here, we've got some silver nitrate, and it's dissolved and dissociated. That's being told to us by the fact that it's aqueous. And we have some sodium chromate. Notice I didn't say disodium, I said sodium chromate because the charge on chromate is -2, which inferred that there would be a +2 total. Sodium has a +1, so it'd be 2 of them. We don't need to have a di in front of that. So sodium chromate is also present. Notice that they're both aqueous, and that's communicating to us that they're both dissolved and dissociated. So really on this side of the reaction we have Ag plus and NO3 minus and Na plus and CrO4 double minus. Now when we mix those together, they're going to form Ag2CrO4, silver chromate, and sodium nitrate. Now it turns out this is going to be a solid. The silver sticks very strongly to the chromate. Now if you come down here, you can see we've got silver nitrate, we've got sodium chromate, all of them in the solutions. We mix the two together, and immediately this orange powder forms. Now what's happened there is our chromate has paired up with the silver to create a formula unit, and that formula unit is going to be solid, not aqueous. So it's going to fall to the bottom as a precipitate. However, Na and NO3 are remaining in solution as ions, and that's shown to us by the fact that it's aqueous. Now, this is the entire thing. This is what we call the molecular expression, or the molecular equation. If we look at the net ionic equation, now think about what net usually means. It means what's the big effect? What's the overall impact? So the overall ionic expression, where we only care about the things that actually change. We start out with these ions by themselves and this ion by itself. They combine, form this solid, and precipitate out. These are going to be the key things participating in our reaction. However, these two things, they stay dissolved and dissociated over on this side, right there and there, and also over on this side. And you can see that I've underlined them on both sides so that it's easy to spot them. They are going to be our spectator ions in this reaction. Now, what if I ran out of this stuff and I wanted to do a demo that day? Well, I guess I just have to postpone the demo, right? No. I can go to the stock room and I can try to find a different salt. I can try to find something else that's also going to be aqueous. Notice that that's aqueous. So the C2H3O2 group is going to be something that does dissolve and dissociate from the silver. And if I can't find sodium chromate, I can find some potassium chromate, which is also going to be aqueous. Now, it doesn't matter to me what this or what this is. They're just spectator ions. They're just there so that this didn't suddenly fly across the shelf and crash into a negatively charged bottle. Because remember, Ag ion, silver ion, is going to be a +1 charge. It's not going to stay in the bottle unless it's got a negative ion to pack in with it. That's the spectator ion. Now in the process, I still get the exact same real product, and the spectator ions remain dissolved and dissociated. We write it as aqueous so that we know that it's there. Also because if we suddenly filtered this out and then evaporated off the water, we would get this salt sitting there as a dry powder crusting on the glass. But if we want to ignore all these other things that are just spectator ions, we can just remove them entirely to help highlight the key piece to notice. And that key piece to notice is going to be called the net ionic equation. The net ionic equation for this was that 2 silver ions and a chromate ion form silver chromate, which is a solid. Notice it has left out our spectator ions entirely. That's the difference between our total ionic equation, that shows everything, hence total, and our net ionic equation, which only shows the things that change from the beginning to the end. And since the spectator ions were always dissolved and dissociated at the front and end, we just remove them.